Hey Jake, and whoever's watching, 9-2, this is part B of the notes. We are on the back side. We just did a critical value method on Thursday, and today we're doing confidence interval method, okay? Ultimately, all right, here we go. Ultimately, what we're trying to get to is where, before we did confidence interval method, we eventually try to get to the point where we're trying to find where mu lives, right? Mu lives between these two numbers. Except since we're talking about two proportions, or two means, it's not just mu that's here in the middle. We're talking about mu1 minus mu2, right? Okay, ultimately that's what we're trying to find, is this number and this number, and we're trying to figure out where he lives between. Now, here's the deal. Our hypotheses always start with the fact that mu1 is equal to mu2. Those are the averages. We're saying the average of whatever two sets of data we're doing are exactly the same. Now, if they are exactly the same, if mu1 equals mu2, what will mu1 minus mu2 be? Zero. So when we do this and we find this number, all we're doing is looking and saying, does 0 live in between there? If it does, then we're going to circle this. If it doesn't, then we're going to cross it off and go with the second one, right? Okay, that's how this works. All right, our second hypothesis, or our H1, is going to be either mu1 is not equal to mu2, mu1 less than mu2, blah, 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 all that good stuff, okay? So I'm going to put that there ready to go. I'm going to have a bell curve here just to figure out our percentage stuff. And let's read the problem. Here we go. Confidence interval. Using the sample data given in example 1, construct a 95% confidence interval. Okay, I'm going to put 95% there. And let's go back up to the first data set. Blah, blah, blah. Example 1, data. Here we go. We're talking about females and males, and we're saying, do females or males have higher course evaluations than the other, okay? From our data, if you remember from Thursday, the males were ranked slightly better than the females, right? Their average score was a 3.99. The average score for females was a 3.87. So, according to this, our males were slightly better than females, right? But in our conclusion at the end, was it enough to say that males are ranked more favorably than females? No. Just according to our data, we had slightly bigger number for males, right? Okay. But there is no difference in male and female evaluations in the long run, right? Okay, so let's get some numbers down here. We were saying our hypothesis was that it was equal to and not equal to. We didn't say one was bigger than the other, so we just say equal to, not equal to. So that's going to be what we have here. We had two tails, and there was, our fish value was 5% or 0.05, which means we have to split it into 2.5. And 2.5%, which still makes the 95% confidence level, right? Okay, that's how that works. All right, from the stuff before, we had males was our one, was it? Yeah, females was our X1. Okay, so we're doing females over here. We're gonna do males here. I'm gonna copy this information down from the front side. Females, X bar 1 was 3.87. Check that and make sure that that's right. X bar 2 was 3.99. Okay, then we have our standard deviation 1 and our standard deviation 2 from the front side. Does somebody have those?
Yep.
Yeah.
1 is 0.56 and
0.56?
yes.
Okay.
And then 0.40.
0.40, perfect. Okay. And then let's talk about N1 and N2. How many females did we survey? And how many males did we survey? One of them was like 12 and one of them was like 15. 12 and 15, right? Okay. All right, there we go, 12 and 15. All right, now we talked about degrees of freedom, and we will have to look up degrees of freedom in this case, okay? Degrees of freedom normally would be either 11 or 14, because I subtract 1, right? Subtract 1. Which one do you go with, though? You go with 11, because you always go with the smaller one, because you never want to assume more accuracy than what you have. So we're going 11 degrees of freedom at 95%, okay? Now, we are doing a mean, which means we still have to decide whether we're going to do the T or the Z chart. T or Z. Do you guys remember the difference between the two?
Yeah.
Which one are we going to use in this case? T. Why? Because each one of them is below 30, right? 12 and 15 are both below 30. So we're going to the T chart. And we're going to look up on the T chart. 11 degrees of freedom at 95%. Somebody give me those numbers. It should be just one number. T chart. 2.201. Did you guys all find it? Yep. Okay, we need that guy. All right, now we need to calculate the error. Okay, we need to calculate the error. Okay, this error formula is not the ugliest formula that we've had, right? Okay, so error, I'm going to make him smaller. So if you want to write him down here.
What's the thing?
The thing in the front, t of alpha over 2, that's just the t value. I just write it as t. So they put alpha over 2 because that means your alpha over 2 means that you have your two tails. So it's like the t for two tails is what that means, the alpha over 2. Okay, so I'm going to write him in simplistic terms. It's just t times the square root of s1 squared over n1 plus s2 squared over n2. That's your formula for error. Okay, I'm going to write him out a little bit prettier than what it's printed above. And that is what he looks like. Okay, so we know our t already, 2.201. And then the rest of it is stuff that we're given. So square root, s1 was 0.56. We're going to square that over 12 plus 0.40 squared over 15. Okay, the square root of that times 2.201, and let's figure out what the error is. Okay, so practice typing that in. Let's see what we get.
I got 0.422.
0.422, 0.422. Okay, let's see if anybody else gets that. Yes, Sarah got that. Okay, all right, so that should be right. Usually if two people randomly come upon the same number, it's probably correct.
What was it?
0.422? No? Do you need help?
Nope.
I would, if I have a dumb calculator, I would do like this chunk right here. And then do this chunk. And then add them together, take the square root, and take it times 2.201. Okay? That's that. Okay, now, in the past, when we're doing confidence interval, we usually take x bar, and we subtract the error, and we take x bar, and we add the error. But this time, we have two x bars, right? So rather than doing just x bar, we take x bar 1 minus x bar 2. We find the difference of those and subtract the error. And then we take x bar 1 minus x bar 2, and we add the error to that, okay? So we find the difference between these two. This guy minus this guy minus the error, and this guy minus this guy plus the error. Okay?
Negative 0.542 for the lead.
Oh, God.
Negative 0.542.
Yep. And
Okay.
then 0.302.
And 0.302. Okay. Do we concur? That's my confidence interval. Okay. Now we're looking to see if 0 lives between there. Does 0 live between there? Yes, it does. So that means we're going to say what?
It's valid.
How do you get 0?
How do you get 0? What do you mean?
What?
Do you see these two numbers right here? These two numbers? Did you get how we got those? Right?
Yeah.
Okay, we're looking to see if mu1 minus mu2 lives in between there. All right,
Okay.
if we're assuming mu1 and mu2 are the same, then mu1 minus mu2 would be 0. So we're looking to see if the value 0 lives in between those two, right? And it does, so we're going to say that they're equal, and we're going to cross this off, which means same results as we had before. I don't remember which one our claim was. The top, right?
The top, yeah.
Claim is the top, okay? So we're going to say FTR, H naught, claim true, which means in layman's terms, males and females are equal.
Okay, wait.
Okay, males and females are ranked the same according, like that's the same results as we got on the front
So,
side,
like,
right? As it should be.
This one. Wait,
Okay.
what?
Actually, I think
No.
Got it?
No.
Let's go real quick to your homework assignment because we're going to talk about the less than greater than thing and figure out what our stuff is, okay? Because sometimes the hypotheses are kind of weird to figure out, okay? So here we go. We are talking about the treatment, and then what is this? Sham?
Yep.
Or placebo, okay? So this is the placebo group. Whatever. They're saying use 1 to determine treatment, use 2 to determine placebo, okay?
How do you find the test?
Determine whether these, blah, 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 blah. I'm looking for the words. Test the claim. Here we go. Part A says, test the claim that those treated with magnets, so the treatment group, have a greater mean than the placebo group.
And mu1 greater than mu2.
Okay? So mu1 is equal to mu2, and mu1 is greater than mu2, okay? Which means we have one tail and etc., right? Be careful because sometimes they'll say this one's greater than this one, but that's actually the second one, right? Like the second one greater than the first one. So then it would be less than in that case. So be careful of that, okay? So that's what your hypotheses should look like. Got it? You're doing confidence interval like what we just did. All right, and there's all your stuff. Okay, let's go down to the bottom one and let's figure out what our stuff is. We have recent values and we have past values. So we have mu1 equals mu2. I'm running out of room. And then mu1 something to mu2. Let's figure out whether we're doing less than, greater than, whatever. Okay, I'm looking for the words to test the claim. Assume that.
It doesn't have the words test.
Do not assume that the population standard deviations are equal. Does it appear that the mean time interval has changed?
No.
So it doesn't say whether it's greater than or equal to, it's just saying, has it changed at all? We have no idea whether that's bigger than or smaller than. So that one is not equal to. So we've got two tails there. Okay?
Which one's a claim?
All right.
Not equal to?
I don't know, probably the top one. Has changed. We're going to claim that it has not changed. I don't know.
What?
Wait, then wouldn't it? Wait, what?
We're going to go with the claim being the top one.
Okay.
But they're going to ask you in particular. So after you've done your like fail to reject, claim, true, false, whatever, and make sure you answer these questions. Does it appear that the mean time intervals have changed?
So do we have
So at the end, put yes change, no change. Is the conclusion affected by whether the significance level is 0.05 or 0.01? Okay, so
No.
kind of. All that's going to do is that's going to change your value for t on your error.
No.
So calculate a new t
No.
and then put that into your formula. Okay, for 0.05 and 0.01. Calculate a new t and see if that makes this like 0 not live there or 0 yes live there from one to the other. Okay, so you will have to kind of calculate it like 1.5 times ish.
I'm lost.
Okay, so change your significance level from 0.5 to 0.1. Do it twice, basically.
Hey, I have a question.
Okay, you're gonna kind of look at them twice.
Come look at this.
Okay. Do we want to say recent is our 1 and past is our 2? Just because that's the way that it goes?
Yeah.
Okay, so let's write out stuff. Do we have an average? Does somebody have an average? X bar 1
I got 'em
and
all
X
wrong.
bar 2. Okay, and then we need S2 and S1. You got something? Do you have something?
I got nothing.
Will you read them to me when you get them?
Yeah.
Are we trusting Marcus?
I did it on my thing.
But did you type all the numbers in correctly?
X bar 1,
Yep.
78.5
78.5.
to 87.6.
Woo! Okay, and the
S2,
treatment is the top one?
I don't know.
Assume that the recent times within the past few years. Oh, eruptions of a geyser. Okay. All right, standard deviation.
1 is 13.9.
13.9.
2 is 7.5.
7.5. Okay, what's X or N1?
17.
17 numbers, and N2
12.
is 12 numbers. So degrees of freedom will be 11. Okay. All right. So use that information. You will have to switch your 0.05 and 0.01. Okay, and make sure you're answering the questions, not just putting claim true, claim false, whatever. Make sure you're answering the questions from there. There's only 2 problems. Okay, it shouldn't be that hard.
Come here. No.
Let me know if you have any problems.
I do.
Okay.
Okay.
All right. Here we go.
Come here.
Goodbye, Jake.